Butlery, and this is my Physics 2211 lab. So the purpose of this lab is to analyze the motion of a slinky, which is technically a spring, while it is in motion, and to understand concepts such as Hooke's law, center of mass, Newton's second law, etc. The three fundamental physics principles that we'll be discussing is basically the gravitational force, the slinky's force, which is really just the tension force, and the drag force. And you can see the equations here. The system that we'll be analyzing is the slinky as well as the earth, and the force of gravity that exerts on the slinky, and the air that causes a slight drag force. The surroundings are all the other observed objects that we don't account for, such as the two people, sound, etc. You can see that the initial conditions are the slinky being held up by the top by your hand while it is in kind of the stretch position, and then the experiment begins when the slinky is released. You can kind of see that this is kind of how the arrangement of the slinky looks like over here. And it's kind of held, and then in that position it's released, and that's how it works. So our basic observations is that the bottom of the slinky stayed in the exact same position until the top of the slinky collapsed into the bottom, and then it began to fall as well. You can kind of see this supported in both the computer model here at the top as well as the actual observed model here at the bottom. And then you can kind of see that the way our glow script operates is that the initial the template I took from previous labs, so it still uses balled up position and balled up velocity and all the rest, but you can kind of see that it basically just defines that at whatever position that it was initially, which I think I set it to like -1.4 or 1.5. And then the ball dot velocity is at 0, 0, 0 since it starts at rest. And then it starts into a loop where there's kind of a time and there's a dt, and then that's being added slowly, and then at each iteration the force net is being recalculated in the way you see down here, and then the force net updates the velocity, which in turn updates the position, and you just kind of take smaller and smaller steps, and it kind of creates an approximation of the value. And for the question that was meant to guide it is the bottom of the slinky stays constant, just like in the video, likely since the center of the mass of the slinky is still dropping and the bottom is held up by the tension force of the spring.